was a question in your revision book for the national test on page 330. It's question 7100. And you've got a tower of cubes, and it's three-dimensional, so I'm not drawing it three-dimensional. But if you look from the side, from one of the sides, you've got a central cube here in the middle. And then you build a new cube on top of this cube all the time. So here we put a new cube on the top. And then around the side, on each of the four corners, you're adding actually one cube here on this side, one cube here on this side, one in the front and one in the back. So that picture number 2 would actually have 2 cubes in height and then 4 extra cubes on the outside. So you'd get 6 cubes. So if we looked, this is a side view, picture number 3 would have 2 cubes on the side like this, 3 high and 3 on each side. So 3 on each side times 4. There's 2 on each side, 2 at the front, 2 at the back. So this is just a side view of what the pictures would like. So in picture number 3, you'd actually have 15 cubes. 15 cubes. In picture number 4, you'd have 1, 2, 3, 4 high, and then you would, from the side, be able to see 3 cubes high, followed by 2 cubes, followed by 1. So 3 cubes high, and then 1 less, and then 1 less. So we have 3 plus 2 plus 1, giving us 6 cubes here on the side. So 6 times 4 for the 2 sides, the front and the back, would give us 24 cubes on the sides, plus the 4 that we would have as our tower. (24 plus 4) giving us 28. So picture number 4 would have 28 blocks. Picture number 5, we would have 5 in our central column, and then we would have 4 in the next row, 3 in the row after that, 2 in the row after that, and 1 in the row after that. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would have 10 lots of 4, because we have a row of 10 here, a row of 10 on the other side, a row of 10 in front, and a row of 10 behind. So we would have 40 loose blocks plus the central column of 5, giving us 45 in our central block. 45 in figure number 5. The same thing for figure number 6. We'd have 6 in the central tower, and then we would have 5 plus 4 plus 3 plus 2 plus 1 on each of the sides multiplied by 4, giving us 45. So here we can see the sequence of numbers that we can build up with this pattern. But the question is, they would like us to be able to determine a formula. They would like us to determine a formula for the number of cubes in relation to figure number. N. So we have to determine what is the function, what's the relationship between figure number n and number of cubes. Well, we have to think what we're doing here. If we look at the figure number, we are working out the number of cubes. The figure number is the number of cubes that we have in the middle. So figure number 4 had 4 cubes in the middle. So it was the central column number, the number that, let's say that for figure number 4 we had 4 cubes. We had these 4 here. This was our starting point. And then what did we do? We added 4 lots of all of the 4 lots of the number of cubes on the sides. Cubes on all 4 sides. On 4 times the number of cubes on one side. So we need to find out a formula in terms of figure number for that. How could we express the cubes on one side? Well, let's have a look at how they are built up. We have 1, 2, 3, 4, 5. We can see that these cubes actually build up a triangle. And there's a very special formula for triangular figures, and that is that it is n multiplied by, not plus, n multiplied by n plus 1 divided by 2. Whenever you see a triangular formula in a building up of a sequence, it should sort of scream out at you, triangular formulation, I have to use the triangular formula, n times n plus 1. But if we look at the formula that we've got for our triangles, we've actually, if we looked back here at 4 cubes, the four cubes was the central number, but the triangle actually had less. It actually started with only a 3 height, so it was actually equivalent to n minus 1. So our triangle started at n minus 1, which is equivalent to our n here. So instead of it being n, it didn't start at 4. Our triangle always started at 1 less than 4. So it's n minus 1 multiplied by n plus 1. Well, what would be n minus 1 times plus 1? N minus 1 plus 1 would actually end up being n, all divided by 2. So because we're not actually starting at the correct figure number, when we're working out the number of triangles we have, we're starting with one less triangle. We have to use our triangle formula and adapt it. So instead of it being the traditional n times n plus 1 divided by 2, we have to consider that for our sequence, we actually start counting the triangles one number less than the one we had. So we start counting the triangles at n minus 1 multiplied by n divided by 2. This gives us a formula here of the number of cubes can be worked out using the formula n plus 4 lots of, and then divided by 2, n minus 1 multiplied by n. We can simplify this to n. 4 divided by 2 is 2. N minus 1 multiplied by n actually ends up being n times n is n squared. And n times minus 1 is minus n. So we get 2 lots of n squared minus n. This can be simplified even further. We get 2 lots of n squared plus n minus 2n. 2 times minus n is minus 2n, and we've got a plus n there as well. So this gives us an expression of 2n squared minus n. So I think that we can represent the number of cubes as being 2 lots of n squared minus n. Let's see if that works. Let's try and plug some numbers into what we've got here. If we take n equals 1, 2 lots of n squared, well, 2 times 1 squared is 2, so that would be 2 minus what n is, which would be 1. 2 minus 1 would give us 1, which gives us the answer of number of cubes. Let's try again for n equals 2. N squared, 2 squared would be 4. 2 lots of 4 would be 8. So we would have 8 minus n, which is 2, 8 minus 2, which would give us 6, which is what we would want. Let's try n equals 3 then. Well, n squared would be 9. 2 lots of 9 would be 18, minus n, which is 3, which would give us 15. So it is possible to work out these sequences and work out the number of cubes. So we have a formula here for the number of cubes as being 2n squared minus n, and it does seem to work for our sequences, and you can plug it into the others and you'll get the right answer. So now we have an answer for our sequence, and the question would be, if we now had to answer the question, how many cubes in figure number 20? Let's just make a little bit of space here. If we had to work out number of cubes in figure number 20, it's quite easy to do using our formula. So if n equals 20, the number of cubes, c equals 2n squared minus n. It would be 2 lots of 20 squared minus 20. 20 squared would be 400, and 2 lots of that would be 800. 2 times 400 would be 800 minus 20. It would give us 780 cubes in figure number 20. So we can just sort of manipulate the numbers by like this and try and use our skills in algebra and sequence understanding to try and discuss everything in terms of n.